Hello everyone, I'm Shahab and this is Noah Academy. In this video, we are going to look at how to balance redox equations using the half reaction method in acidic solution. Ready? Let's go. Now, balancing redox equation is a little bit more challenging than just balancing a regular chemical equation. Just because here you have to balance not only the individual atoms but also the charges. So this is a redox equation, which means that there is oxidation and reduction. We want to know which elements are oxidized and which are getting reduced. We can figure this out by looking at charges of the oxidation number of these elements. So the first thing we are gonna do is assign oxidation number to each of the elements in this equation. Take a look at this table, it might be helpful. Now let's start with Ag. Silver is an element by itself. It's not combined with any other elements, it's just on its own. That means its oxidation number is 0. NO3 minus, it's a polyatomic, so it doesn't follow any rule, so we have to figure it out. Oxygen is usually -2, except -1 in peroxide. And here it's definitely not a peroxide. So the oxidation number for oxygen is -2 in this compound. There are 3 oxygens, so I'm gonna multiply this -2, it's going to be -6. Now let's figure out nitrogen oxidation number. We are going to use this rule. The sum of oxidation numbers for polyatomic ion equals ion charge. Ion charge here is -1, and that means that whatever nitrogen oxidation number is added with -6 has to give us -1. So that means nitrogen is +5. +5 -6 equals -1. Now let's move to the other side. They are not necessarily to be at the same as they were here, because oxidation can change when the element is in different circumstances. So Ag now has a positive charge for one oxidation number. So the oxidation number of Ag is going to be +1. Now let's move to the NO over here. We don't know nitrogen oxidation number, but we know the oxygen is going to be -2. This rule here for neutral compound, the oxidation number have to add to 0. It's definitely a neutral compound because there is no charge, which means to add together to get 0, nitrogen is going to be +2. Now in the equation, let's see which of these elements is oxidized and which of these elements is reduced. As you can see, Ag was 0 and it became +1, so it lost an electron. So Ag is oxidized. Now let's look at the nitrogen. It was +5 and it became +2. So nitrogen gained electrons, so it's reduced. And oxygen was -2 and it became -2. So nothing happened to oxygen. Now in this step we need to write half reaction, oxidation and reduction separately. As we said, Ag 0 became Ag plus, and NO3 is reduced, so NO3 minus NO. The next thing we are going to do is to balance each of these equations separately. Let's start with the reduction equation. On this side of the reaction we have nitrogen and oxygen. On this side we have nitrogen and oxygen as well. Here in this side we have one atom of nitrogen, and here we have one atom as well. Let's move to the oxygen. We have three atoms of oxygen on this side. On the other hand, we have one atom. So nitrogen is balanced on both sides. Now let's move to the next step. I'm going to add H2O to balance oxygen and H plus to balance hydrogen. So over here on this side, imbalance oxygen over here. Oxygen on this side is 3 and here is 1. So I'm going to add H2O to balance the oxygen. But over here, I have 3. So I need to add 2 atoms of oxygen. So 1 plus 2 is going to be 3 atoms. Now oxygen is balanced. But now I introduced a new element. Hydrogen is here. So we have hydrogen over here. We have 2 times 2. So we have 4 hydrogen over here. And on this side, we don't have any hydrogens. And here, to balance the hydrogen, you need to add H plus. So you are going to add 4 hydrogen plus. So now the equation is balanced. The elements is balanced. But now I need to balance charges. Let's start with this side. Over here, we have 4 H plus. Each one of the H atom got positive charge, so I have 4 plus. And over here, I have negative 1. So positive 4 minus 1 equals 3 plus. And over here, I don't have any charges, so it's so much simpler. So the charge here is 0. I need to add electrons to balance the equation. So which side I'm going to add electrons? Surely over here. So I'm going to add 3 electrons. So electrons have negative charge. So positive 3 minus 3 equals 0. So now finally the equation is balanced. Now let's move to the oxidation part. But here it's so simple because we don't have any O's or any H's. So the atoms are balanced. So now we need to balance the charges over here. We have 0 and it became positive 1. So we need to balance the charge. So we're going to add electron over here. It has negative charge. So plus 1 minus 1 equals 0. So this equation now is balanced as well. Finally, the final step. We are going to multiply the electrons on this side to be the same or have reaction of the reduction on this side. So we are going to multiply all of this equation by 3. Consider it as a math equation. 3 Ag, 3 Ag plus, and 3 electrons. The final step, let's combine them together. So we have 3 Ag plus. On this side we have 3 electrons plus 4 H plus NO3 negative. We have over here 3 Ag plus 3 electrons NO plus 2 H2O. Now over here on this side you have 3 electrons, and on this side you have 3 electrons as well. So you don't need to add them, just remove them, and this will be the final equation. 3 plus 3 Ag plus NO, and that's it. Thank you for watching.